So this problem says without graphing, determine the number of solutions to the system of equations. Now, I may rely a little bit on graphing, uh, just to give you a broader sense of what's happening. But ultimately, you don't need graphing to solve it, but it'll be there as a helpful reference, mental tool. This equation here is in what by now I think we know is slope intercept form. And the reason it's called that is because you can take a look at this one and we'll write it down here. That's the intercept. Now it's the y-intercept. Now, something you need to remember when the y-intercept, when you're looking at the y-intercept, the x is always 0. Because you're looking at, just kind of back to the graphing thing, you're looking at that point here. That's the y-intercept. In this case, this is 0, 1. And then the other thing you can gather from just looking at the equation is that the slope is 5. So you know that if you go up 5, 1, 2, 3, 4, 5, and over 1, because this is rise over run. So 5, 1. Okay, forget my poor spacing. And that's not a minus sign, that's just an equal sign. That 5 is the rise and 1 is the run. Okay, so we know that's what that line looks like. If you understand what slope intercept is, you don't even have to draw the picture. You can generate this picture in your mind. Okay. Now, the other equation, and I think I'm going to actually erase this here. So now you should have an idea in your mind based on those two pieces of information. This other equation, it's a line, but it's in standard form. Standard form is always going to be ax plus by equals c. Now, standard form is nice in some situations. There's some situations where to model the situation, you're going to write it in standard form. Okay. We'll get into that later. It's also sometimes useful to, if you're thinking of graphing, we might as well, since we did a rough sketch of a graph. It's nice to have things in standard form because you can find the x and y intercepts. So if x is 0, y is 5. I'm not going to do all that work, but if you plug in a 0 here, you'll solve it and you'll find out y is 5. And if you plug in a 0 for y, you're gonna find out that x is -1. So that's one way to just graph this equation on its own. So 0, 5, and -1, 0. And of course you can have that line. And I think we had another line. We had another line on here. That went something like this, roughly. That's for the y equal 5x plus 1. Okay, so you can almost, now I'm using graphing, right? And I can almost answer the question at this point. And maybe I need to say what it means for there to be a solution. But I think when they say graph, I'm sorry, without graphing, that what they want you to do is to take this equation and rewrite it in slope-intercept form. And I'll tell you why that's going to give us the answer. So they didn't say don't use algebra. They said don't use graphing. So even though I've shown you the graph to give you a general idea of what's happening, let me take this equation that's in standard form and put it in slope-intercept form. So subtract 10x. Now, we like to write the minus 10x in the front. Divide by -2. Now, assuming I did that right, and let me double check my work. Subtracted 10x divided by -2. Okay, so actually, turns out I actually didn't, like I drew a fair picture, but not the best picture. And this is how I know that my picture is not very good, but that the algebra actually is more helpful. I want you to look at the slopes. They both have a slope of 5. That actually means that the lines are equally as, now I'm going to draw a picture just to bring this home, but you don't need the picture. The lines are just as steep. How do I know that? Because they have the same exact intercept. I'm sorry, slope. Now, they may have a different y-intercept. We already said this y-intercept was 0, 1. Now this, how was this one? This one is 0, 5. But the bottom line is that if lines have the same slope and a different intercept, they are parallel And therefore, because they don't intersect, there is no solution. The solution is the intersection point where they meet. Because they're parallel, these lines will never meet, and therefore there's no solution.